Hey everyone, in this video we are going to sketch a polynomial function. Now we use the word sketch instead of graph because when it comes to polynomials, if you want to find their nice curve, smooth, continuous, could be a line, could be a quadratic, a cubic, but in order to find maximums and minimum values beyond quadratics, you need a calculator or calculus. And because we're not doing that, we can't really call it graphing. It's more like we're just sketching, okay? Because your x values will be precise and accurate. Your y values beyond the x-axis are flexible. So I'm not going to do this on a graph that's already made. I'm gonna draw it myself, so you'll see what I mean. Now I have a few steps for doing this. I have my little mnemonic device that makes no sense. We could change the order and make it say something. If you could think of something where I just shuffle a couple things, like you'll see what the steps are. G has to be last, but there is some flexibility with like the E and stuff. So we'll see. I'll appreciate, put it in the comments. That's what I'm trying to say, because right now this is just a weird sentence. I like to say exotic funky zebras avoid purple little grapes, but it would be great if you could just pronounce that, you know, like PEMDAS. F zaplug. No, not a thing. So E is for end behavior. Well, you have, so end behavior, right? You have a negative leading term, and you have an odd degree. The degree is the largest exponent when you're in standard form. If you're in factored form, you have to consider it as if it were in standard, okay? Odd is referring to the 3, the negative right there. Anything negative for end behavior will be pointing down on the right. I always do the right side first. And odd, I think the word opposite. So if you're down on the right, then you are up on the left. So end behavior, done. F is for factor. I don't know why I checked it. I'm not done. But let's start with GCF. Always start with GCF. Not that hard to remember, but everyone forgets. Negative x is certainly my GCF. If your leading term is negative, you've got to use a negative GCF. You have to, at the very least, just a -1. At least. Negative x, going to factor that out. That's going to leave me with x squared minus 4x minus 5. Negative x can stay. Could you put parentheses around the negative x like that? I guess. It's weird. Could you even write x minus 0? I mean, I guess. Also weird. I just want to give you options. This is a quadratic trinomial. If you need help factoring, please go find my factoring playlist. Find the videos where I do this type of problem. X times x is x squared. 5 is prime. We don't have many options. 5 and 1. I need to multiply to be a -5. That means I'm going to have a negative and a positive. And I need -4. That means the bigger number is negative. Done. I'm just going to rewrite it like this. It's a little weird with the x minus 0, but again, options. Now, it's y equals right now. Factoring is done. Z is zero product property. So that means you said each piece, each factor, factors are what you multiply to get a product, hence the name zero product property. We're setting it equal to 0. What are we really setting equal to 0 when we do this? Really, you're replacing y with 0. what do you get when you replace y with 0? X-intercepts. So what are we about to solve for? Our x-intercepts. So we get x equals 0. Done. If you did this, we get x equals 5. And if you do this, we solve and get x equals negative 1. 1, 2, 3. Zero product property done. A is for axes. So we're going to draw our xy axes, and we're going to only fit out our axes to include 0, 5, and 1, and negative 1. So we don't have to go too crazy, you know? So, negative 1, 0, and 5. Okay. Axes are done. P is plot points, which I was getting ready to do. X-intercepts are all plotted. Next. L actually has 2 jobs. 2 L's. L is local behavior and label. The local behavior is determined by not a degree. The degree was 3. That's the degree. We call this power on each factor. Those are called your multiplicity. Since the multiplicity is 1 for each of them, that means that your local behavior is linear at each of them. Local behavior is saying, like, if we just look at it through like a little spotlight, locally, how is it behaving? Okay, it's behaving like a line. It's going to slice right through the x-axis. So local behavior, label. Oh, and when I plot, I could also put down my end behavior. So down arrow, up arrow. That could go with plot. Label and local behavior, done. And then G is graph. Linear, so I cut straight through. Okay? If you want to see what quadratic behavior, cubic behavior looks like, again, go. I have a ton of videos. Go. Watch them. Now, when you draw a polynomial, it's got to be smooth, no pointy. Now, I cut through my x-axis like a line. I'm going to turn around. I know that some people will be like, but that's quadratic. Not at the x-axis. It's not. It's like in the quadrant, you know? Now, again, linear behavior, you're going to cut straight through. So make sure that's round. Again, I'm kind of really committing to this in a pen, so pretend it's a little rounder. And then I'm going to turn around somewhere. Again, nice and smooth. But when I get there, at the 5, it should be pretty straight. So if somebody just went like that and looked at it, they're going to be like, oh, looks pretty linear, you know? Sorry. And that's it. You're done. Arrows, of course. What kind of maniac doesn't put arrows at the end of their graph? So everything important is labeled. And that's the end of it. There you go. If you're happy and you know it, give a thumbs up. If you're cranky and hate everything, put a thumbs down. Hope you feel smarter. Good luck on your algebra finals. Keep checking out videos for practice, and bye for now.